Consider the questions below about solubility and temperature. First, you add 45 grams of KNO3 to 100 grams of water at 60 Celsius. To what temperature must the solution cool before the solid precipitates out? Another way to say this is, at what temperature will 100 grams of water no longer be able to dissolve 45 grams of KNO3? Here's our curve for KNO3, and if we look at 45 grams, that's going to cross right around 30 degrees Celsius. Next, you saturate 100 grams of water with NaNO3 at 60 degrees Celsius. The solution cools to 20 Celsius. If you agitate the solution, how much NaNO3 will precipitate out? Here's our curve for NaNO3. And again, we're saturating it at 60 Celsius, which is going to involve putting in about 125 grams of NaNO3. Then that solution cools down to 20 Celsius. At the cooler temperature, only about 87 grams can remain in solution. So if we take the difference, we find 38 grams will agitate out, or precipitate out. Part C reads, how much water at 50 Celsius is needed to fully dissolve 17.3 grams of cerium sulfate? Here we're going to need to read off the chart and then set up a ratio. Here's our curve for cerium sulfate. And at 50 Celsius, it looks like about 5 grams of cerium sulfate will dissolve in 100 grams of water. However, we don't want to dissolve 5 grams, we want to dissolve 17.3 grams. So we're going to have to use the information we read off of the chart, which is right here, to solve for a different amount of cerium sulfate. And it turns out when you do this math, you find that you need 346 grams of water. Part D is similar. How much KClO3 is needed to saturate 85 grams of water at 36 degrees Celsius? Here's our curve for KClO3. And we see that at 36 Celsius, 100 grams of water are able to dissolve right around 14 grams of KClO3. Remember again, this chart is showing us per 100 grams of water. Again, we want to set up a ratio here, and we're trying to solve for how many grams of KClO3 are needed to saturate not 100, but now 85 grams of H2O. And when you solve that math, you find that X is equal to 11.9 grams KClO3. Lastly, you attempt to dissolve 65 grams of ammonium chloride in 100 milliliters of water at 40 Celsius. How much actually dissolves, and how much more water will you need? Here's our curve for ammonium chloride. We're at 40 Celsius. So at 40 Celsius, we see that right around 46 grams do dissolve. We attempted to dissolve 65 grams. Only 46 of those grams did, which means that we're still looking to dissolve 19 grams. We can set up one last ratio. 46 grams of ammonium chloride dissolve in 100 grams of water. We're trying to dissolve 19 additional grams of ammonium chloride in some amount of water. And we find X is equal to 41.3 grams more H2O that is needed.